Starting. All attendees are in listen-only mode.
Good afternoon, everyone. This is Mark Albert, Editor-in-Chief of Modern Machine Shop Magazine. Welcome to our webinar sponsored by FANUC America. Thank you for joining us. Our topic this afternoon is CNC Programming Made Easy with Manual Guide I Conversational Program, Part 5, Probing. Without particular knowledge of G-code programming, it is possible to generate part programs on the shop floor by answering simple questions. FANUC's Manual Guide I Conversational Programming provides this capability for milling, turning, and mill turn centers with FANUC CNCs. Part 1 of this series gave an overview of the functionality of Manual Guide I. Parts 2, 3, and 4 built on that introduction by reviewing the entire progression of creating a basic turning and milling program with Manual Guide I. Today, as Part 5 in this series, we'll look at basic setup and operation of the probing cycles within Manual Guide I, both on the manual side plus cycles on the auto mode that can be inserted into your G-code programs. We'll also discuss work coordinates, tool offsets, and measurement cycles that are standard within Manual Guide I. Our presenter this afternoon is Jody Michaels. As National Sales Manager of FANUC America, Jody Michaels' focus is on servicing and supporting end users to maximize their productivity with the use of FANUC CNCs. Jody has more than 35 years' experience in the machine tool industry with various positions in sales, support, automotive applications, and training at machine tool builders, end users, and CNC suppliers. He is a true expert on CNC programming and the functionality, setup, and use of Manual Guide I. So as we listen to Jody during the presentation, please feel free to share your questions with us by typing them in the questions pane on your control panel. He will answer those questions at the end of the presentation. Keep in mind this webinar is being recorded, so you will be able to view the entire program online later. Thanks again for taking time to be with us for the live program. Here's Jody.
Thanks, Mark. And as you say, today what we're doing is Part 5 of our presentations on Manual Guide I, and we are going to concentrate today on the probing. And again, as we did in Part 1, where we sort of went over the setup and everything you had to do to set it up to do a program, today it's sort of the same thing, but it's only going to be on probing. Because probing within Manual Guide I, it's very powerful, but it does take a certain amount of upfront setup. And as I emphasized in Part 1, it's going to save you a lot of heartache if you sort of go through some of the steps we're going to go over today, because even though it is powerful, it's only as good as how well you set it up. But again, what we're going to do today, we're going to show the basic setup and operation of the probing cycles within Manual Guide I. And you have two different types. You've got manual ones where you can just go do one single thing, or there's full-blown automatic cycles that you can do for a variety of different things, whether it's measuring tools, setting your work offsets, or actually measuring features on the parts themselves with, G-codes that you can insert into a full-blown Manual Guide I program, or a program that you actually make offline on a CAM system. You do have the capability of importing that into Manual Guide I and then adding these cycles to that program. And we're going to go step-by-step instructions on how to do this to set your work coordinates, your tool offsets, and the measurement cycles that are standard within Manual Guide I. Now, the first thing that you obviously you want to make sure that you have the right options, in your machine. Obviously, number one, you got to have Manual Guide I. At some point in the future, some of the probing cycles are going to be resident outside Manual Guide I. At this point, we're not up to that, so we're only concentrating on what's within Manual Guide I. And then also you want the advanced guidance function. And then for some of the the tilted plane things that you can do in 5-axis type work, you'd want the tilted working plane indexing function. So these are 3 options that are critical that you need these before you start using manual guide eye probing. Then there's certain parameters that you need to set. And what these parameters are, mainly they go from parameter 12,381, and all these are setting up P-code macro variable areas. And I know everybody out there that's listening, they understand what that is. Because what it does, when you press a button, it jumps into this macro, and then manual guide eye performs whatever that macro determines to do. But it's important for all these cycles to work that these be set correctly. And they go from 12,381, 383, 384, 385. And again, these are all just P-code macro variables, all the way up to 386, and then also 388. And in order to do this, to be successful, like number 2 on my list here, it's important that you have one of these 2 manuals that I have listed here, because within these manuals it goes step by step by step of how you can actually set up the probing cycles. So between what we talk about today and looking at those manuals, because, frankly, I work for FANUC, but I know sometimes our manuals, sometimes they're difficult to understand. So that's what I'm trying to address today, to, sort of fill in some of the blanks that maybe the manual doesn't talk about, so that's what we're doing today. Also, if you're going to use the manual functions on manual guide eye, there's going to be some ladder logic changes that's going to be made to your machine. So some of your builders will do that up front, some of them do not. So it's critical that, if you're wanting to use the manual functions of the probing, that you go in and check it, and if it's not correct, if it doesn't work, chances are that your builder has not, did the ladder development necessary to make it work. So it's important that you test that out before you get all frustrated when it doesn't work when you try to use it. Okay? Again, number 2, you need one of these manuals, and these are 2, it's the same number, it's just 2 different versions. The 01/07 is the newest version. These will greatly assist you when you're setting this up. And then another thing I try to emphasize whenever I talk to customers is that when you go to set this up, it's going to be something that you're not going to set up in 15 minutes. You should allow yourself a day to make sure you get everything set up and you understand how it works. And, if you have to do any ladder development, don't be under the impression that when you set this up, it's going to be a 15-minute job. It will take longer than that. Also, the number 3, another key for successful probing setup is that, with most spindle probes, when they go into your spindle, whether it's in a tool on a lathe or whether it's a spindle on a machining center, in order to turn that on, typically builders will have an M code associated with that. You have to make sure that within your manual guide eye that you build some type of fix form, if you're going to put it in a program, when you call that spindle probe up, that you turn the probe on. Because if you put it into the spindle and try to do a probing cycle without turning it on, bad things happen. And the reason I know that is because I've done it myself before, where I've worked on certain machines where I thought an M code was going to turn it on, that didn't. So it's critical that you know what that M code is and then that you implement it whenever you want to use a probe. So if you're going to do manual cycles, you have to go in MDI and turn the probe on first. Okay? Again, I want to emphasize that. Make sure that you know what that is and either make a fix form for the automatic side, or when you're doing the manual side, you go into MDI and turn it on first. Now, when you set up the manual guide eye probing, when you first go into the screens, the first thing you want to do is go into jog or handle, and then you press the settings hard key, and it takes you into a screen where you actually go up and set different values, because in order to run any cycles within the probing, you have to calibrate all of the different, it has to know the length of the probe and then the diameter of the stylus on the probe. Also, you have to go in and tell it the group number of the tool measure calibration, because you can have up to 6 different ones. 99% of the time, you're only going to have one, but it's critical that you go in and set this up front. And also, you go in and, again, tell it the tool measure conditions, however many work set conditions you're going to have, and then the one down here, the height of plane put reference work. It's critical that you put a value in there, because basically what that's telling manual guide eye is where the face of the spindle is on the machine in relation to your work offsets. So it's important that you have a value in there. Usually it's like your reference point, or if you have a machine that's like a 5-axis, it'd be parameter 19,702. It's important that these be the same value, so that when it does the calculation for how long the spindle probe is, it looks at this first. And then these are just a couple examples of ladder development. I just wanted to throw these in so that you guys could see some of the things you'd have to do in order to develop your ladder on your machine. And again, this is just another one where within manual guide eye it does the measure cycle. Now, when we actually go into our manual guide eye, I'm going to go to a different screen now at this point. I'm going to go back to NC Guide. Now we're sort of going to go through some of the screens actually in manual NC Guide. And the first thing when we go into manual, we want to go into our jog mode. And you can see this up here on top of the screen. And as you can see, if we go to edit, we get different soft keys. If we go into jog, it goes to this. And then just to go over again, just so we're on the same page, if you guys call me with questions about this, all these keys at the bottom of the screen, they're soft keys. This right arrow and the left arrow keys, I call those right shift or left shift. So that's just so we're on the same page. So if you call me at sometime in the afternoon, we're on the same page when I say a soft key or a right shift or a left shift. But then to actually get into the setting page, there's the settings, and then it takes you into that to where we go in and do all the calibration and everything that we discussed. And then we go left shift to go back to the measure screen. And then within the manual measure screen, as you can see, we got a whole host of different selections. As I say, the probing cycles are very powerful. And just to discuss, the timing of what we're doing today, mainly I'm going to focus today on the manual part of it, because there's a lot of things you can do within the manual side. And we're going to sort of go through all these. So we're going to get through as much as possible. Hopefully at some point we're going to have a part 2 of the probing too. But we select any of these, like probe length calibration. We select that, and see it brings up another screen where, again, with manual guide eye, whenever you do a cycle, if it's going to give you any answers, there'll be a soft key here. So see at this point it says measure direction, measure condition, and reference work height. So you fill all those out, either X minus or Z minus. Usually on a probe length calibration, we're going to do Z, and see it fills that in. Then you go down to the next one, and then for the work height, 2.0. And so you just go in and set everything up. Then here, what it does is when we do the first one, you have a measure soft key. Once we get all the conditions met, you press measure, and what it does, it goes down and measures the tool once, backs off, and then goes down and does it again. Whenever it does a measurement cycle, it always does it twice. Okay? So that's our calibration cycle. And again, this is something you have to do before you go in and try to run a cycle. You have to go through these calibration cycles. All right, then the next one we want to talk about, the stylus ball diameter calibration. You select that. And again, it's just fill in the blanks, just like we've talked about the previous 4 webinars that we've done. You know, the great thing about Manual Guide I is that once you've done one cycle, whether it's a turning cycle, a milling cycle, a boring cycle, or whatever, or a probing cycle, you know, they all look similar. They're all just fill in the blanks. So on this, you know, the first thing it asks is a reference work diameter. So basically, when you set up to measure the diameter of the stylus on your spindle probe, you will put something on your table, or if you have a feature on the table, a hole in the table where you know it's a known diameter. Obviously, you want to have something that's got a relatively good finish and it's relatively round, because the better the measurements are on calibrating your stylus, the better things will be when you actually set a work offset. So it's important you have like a ring gauge or a part that you went in and finished board or whatever. But again, you put a work diameter like 2 inches. Then again, it's just fill in the blanks. So see, it asks you what your work plane is, whether it's X, Y, or YZ. Again, the measure condition. 99% of the time on this measure condition, it's going to be number 1. The only time you'd have more than that is if you got more than one type of condition that you're trying to meet, and you're almost never going to have that. Then, again, it asks you to measure 4 different sides of whatever the ring gauge is or the feature on your table or whatever round surface that you're using to measure that. And see, then at that point, again, it shows a measure key. So again, you just go into, you press measure, and what it does, it goes over and touches one side. You press measure again, it goes over and touches the other side. You go all the way around it, and from that, it will figure out the diameter of the stylus itself. And it'll put that into a variable of one of the screens that I showed you before, so that it knows exactly the radial diameter of that. So again, it's critical, number 1, that you know exactly the size of the origin, this reference work diameter. Because again, as I say, it's critical. The more precise you are there, the better off you're going to be. Okay. So that's our diameter calibration. And then also you can do an offset calibration with it. You can have it to where it's offset one way or the other. Okay? So you got 3 different types of stylus calibrations. You got the standard, which 99% of the time you're going to do that. The other 2, you can have it offset one way or the other. And like I said, very rarely have I've never used either of the second 2. I always use the first one. But again, it sort of depends on how you're doing it. But again, 99% of the time, it's going to be number 3 here. Okay? So those are our different selections on the probe calibration. Then also we have a touch sensor. And what this is say on a lathe or a machining center where you'd have something that was going to measure the lengths of your tools or the diameter of your tools. So, you know, it's like on a Renishaw, like a TS27R or a Bloom measurement that goes directly on the table for measuring the lengths of your tools. So that's what this is for. And again, it gives you a choice of which the measure direction is, also your condition, and then your reference tool length and reference X offset, and then measure condition and which axes you want to measure. So again, you can set this up not only for a spindle probe, but also a tool probe. So again, it's very powerful. It'll do a lot of different things. So that sort of gets us through all the different tab 1, just the calibration cycles. But again, you have to go through these before you go on to the others. Because if you try to go on and do, if we go to the next tab where we do tool measurement, if we wouldn't have went through this touch sensor measurement, it wouldn't work. So we'll go into our next tab. This is tool measurement. And this is usually, it can either be for a lathe or a machining center, but you give it a tool number, the direction it's going to measure, whether it's X, Y, Z, plus or minus. Again, your measure conditions. Again, it only has one, so you don't get a choice. And then you tell it whether it's going to be a geometry or a wear offset, and then you just go measure. You press the measure button. It approaches it. Again, it always does it twice. It always does it twice. It'll go down and touch it once, back off, come back down and measure it again. So that's the tool measurement tab. Now the next one we have is our work set. Now I think from the measurement side, on the manual side, this would be the one that you or your operators would use. Because, in my travels, and I've done a lot of training over the years and still do it. I won't be doing it as much now in my new role. But, I would go into, different shops and be training operators. And, they might have a spindle probe, but it was always tied to a particular cycle where you have to run it in automatic. And, they always wanted something manual. What's good about this? It is manual. You don't have to really know a lot of different G codes or anything like that. It's got a pretty picture associated with it. So it's fairly simple to go through the process of, like the first one, single surface measurement, probe Z-axis. People always want to, on a machining center, they want to touch the top of that part and do it quickly. And so with this, if we select that, and again, it gives you a choice of which direction we want to go. X plus, X minus, all the different directions. So we go Z minus, and again, it's 1. And of course, it comes up and tells me that I don't have the parameter set, and that's correct because in NC Guide I can't do that. And then I go in and tell it what my work coordinate is, and when it touches the top of the part, what I want that value to be. The way I program, I'd always make that 0 or some minimal plus amount, but that's what it wants there. Then once you do that, you press measure, and what it does, it goes and figures out the difference between where you're setting and the machine position, and then once you go back to the other side and press set, it'll actually put a value into one of your work offsets, whether that's G54, 55, whatever, one of our 62 different work offsets. So it makes it very simple for your operator. Within 5 minutes he can do this. Once he gets used to it and he's used to navigating the different screens in Manual Guide I, it'll be within a minute or so he can do this. So it's very important that they go through this. Also, we can also do the same thing for X-axis. And, it's basically the same thing, where you just give it a direction, a condition, the work offset that you want to dump the value to. And again, if you're touching on X on one side or the other, it'll do the figuring from there. So it makes it very simple for your operators to do this. And again, that's sort of why I'm emphasizing today just the manual side of it, is because, more and more we want operators that, number one, we want to make it simple for them, and then make it as precise as possible. And with this, you can be very precise because you're using a spindle probe. And also you can do an outside diameter work setup. And with that, say you got a round surface or a square surface, where you want to touch on both sides. Because, when I learned to be a machinist, when we would, if we had something where we wanted to make sure we ended up in the middle of the part, that's what we would do. We'd come and touch one side of the part, then we'd touch the other side of the part, write down those values, and then subtract them, and then divide it by 2, and then that's how we ended up in the middle of the part. So you had to do all the figuring yourself, whether you had a piece of paper that you were doing it. With this, the control will do all of it. It'll do all of it. But again, it gives you a choice, either XY or YZ plane, the measure condition, and then it sort of walks you through everything you got to do. First measure point, second measure point, third measure point, fourth measure point. So you can go through and measure all the way around it, and then it figures out where the middle of the part is. It takes that calculation out of your hand, which is a very good thing. Given, at this point in manufacturing, we're getting to where it's much harder to find qualified machinists. So manual guide eye will help that greatly because, it sort of takes some of the questions of how operators do this. The control will help them do that figuring. And then once you fill out all those, you tell it what the work coordinate is and what you want the X and the Y value to be, and then it does all the figuring for you, and then that puts it in whatever work coordinate that you want it to be. It does all the figuring for you. So it's simple, but it's powerful. Then if we go back, also within that, we can do the same thing if we've got a hole in a part. But again, to emphasize again the simplicity of manual guide eye. Just like I've been preaching this the previous 4, once you've seen one of these cycles, they all look similar. So your operators or your programmers, they'll get to where they're so comfortable with using this, it'll make it very simple. But again, if we're going to do an inside measurement, again, you got a measure plane, a condition, and then the 4 points again. It's just we're on the inside again. You tell it the work offset that you want to use, and then the X and Y value, and then you press the measure key, and then once it does that, it'll put a value into this window, and then once you do that, you press set, and then it'll actually dump a value into your G54. That's what I typically use. So it's very, very good for that. Also, within manual guide eye, we also have where if you have a feature where it's just a rib or whatever the feature might be that's sticking up vertically, you can also measure on the outside of a rib. So again, a measure condition, the different directions, measure condition with the 2 points that you got to touch. You can see the red dot goes from one side to the other. And again, just a matter of setting up your work offset and what value that you want it to be, whether to the side, to the center, or to the other side. So it's very powerful. And again, over the last 4, I've also talked about the flexibility of manual guide eye, because with this, again, it sort of gives you a choice of where you want to go. Because, like I said before, typically when I measure something, the way I was trained was, the top of the part was Z0, and the middle of the part, wherever that is, whether the part was symmetrical or whatever, the middle of the part was always X and Y0. That's how I figured it. But there's a lot of other people that use it in different ways, so that's what's good about manual guide eye. It gives you the flexibility of whichever way you want to go, it'll let you do that. So again, flexibility is a key. Then also within that, you also can do an inside groove or whatever. Again, just pick out your measure condition and direction, and then it shows you what you need to do. And again, that's critical for your operators that's not as experienced. It shows them a picture of what they need to do. And then again, you set your work coordinate, the work coordinate value. Again, you press measure, the measure key, and then the set key, and it dumps the value into your work offset. And again, just to underscore, also within this, on the way I've got this control configured, because as I said, I'm using NC Guide, which is our offline software package that simulates a CNC control. But you can also do the C-axis outside. And with this, again, you get measure conditions, and then see it tells you to go to the plus C-axis side and the minus C-axis side. So it gives you a capability, and you could change this from C to B or A, based on different configurations of different types of machines. It just, for the machine I've got configured, it uses C-axis. And again, you just give it a work coordinate value and then the right work coordinate. Okay? Then also we do inside width work setup, but again, it's basically the same thing. And with it, again, just fill in the blanks. And then again, you press the measure key. And I know I'm beating this into your head, but I just want to make sure that you understand that basically they're all the same. And the last one within it, that was our last one. So again, that's all your work set cycles. And again, like I said, they're all fairly similar, and they're very easy to manage once you understand what they want. But again, I just want to go back again to make sure that you remember that none of these will work until you do the calibration. You know, it's important you do the calibration beforehand. And I can't emphasize that enough. I don't mean to keep going back to it, but I just want to save you heartache up front, and plus I don't want you calling me, you know, saying, well, this doesn't work. Usually, you know, I can tell by the alarms, it's where you didn't calibrate it. So the next one we want to do is the measure function. And what you can use this for is this will tell you if you have a feature on your part or if you have to maintain a certain length or whatever on a part. You can almost use it like a CMM. It'll tell you the size of a bore or a size of a turn or whatever. So it's very powerful in that matter. But again, if we select that, again, it's just fill in the blanks. Measure conditions, and then the tool offset kind, where you want to stick it, and the target value. Okay? That's on Z. Then we can also do the same on X. Again, just fill in the blanks. It's very simple, just like before. You have your measure key, and I know we don't spell measure right, but that's a translation thing. And then you press the set key just like you did on all the rest of the cycles. All these cycles look similar. Okay? Then we get into the outside diameter work setup, and what this is for is for actually you can go in and measure the size of something. And you can have it dump it into, there's actually a field within Manual Guide I where it will maintain a list. You know, say you're doing the same part over and over and over again, where you have to maintain some sort of tolerance on a part. You can go in and measure individual parts, you know, whether it be every 5 or every 1. You know, before it comes out of the machine, it would do a measurement. That's what you could use this for. And you could do it, again, for several different modes. You know, you can go outside diameter, outside width, inside width, and again, you know, all of those. So it's very powerful when it comes to that. Okay? So those are the 4 tabs that we have on the manual side. Okay? Again, I'm not going to go back over these, but they're all fairly simple. You have to calibrate. Again, I can't emphasize enough that you need to do this calibration up front. Then you can do your tool measurement, your work set, and your measure cycles. Again, like I said, the main ones you're probably going to use is the work setting. Your operators will love this because it's simple, it's easy, and you can do it in a couple minutes. Okay, so those are all of our measure cycles within our manual mode. And again, to access this, you have to be in the jog mode. Now, to go on from there, to go into our other cycles, you have to be in edit. And then once you go right shift, you see we have another screen here, and measure cycles, MESCYC. That's what that stands for. When we press that soft key, that gets us into basically the same kind of tabs that we had on the manual side. The only difference between this side and the other side is that within this, when we do one of the tool measure cycles the work set, or the measure, when we create one of those cycles, we can actually dump it into a G-code program. And then it'll be just like all the rest of Manual Guide I. It will be a four-digit G-code that it will run in any G-code program, as long as, you know, it's a FANUC control, obviously. And again, it could be something created on CAM system, and you could put this probe cycle within that. So it's very flexible from that standpoint. But again, we have the same four. And the thing about this is, if you say we look at the probe length calibration, you know, it's a little different. But when you measured it manually, it's still going to put those values in the right condition. But again, we tell it the measurement condition, the reference work height, where you are in X and Y. And the reason you need more of this is because this is going to do this automatic. This isn't going to be something where you go position it manually and then press the button and just goes and does one thing. That's why it needs a little bit more information here. So that's why it asks you a lot more here. And then it asks you for a feed rate. And then it gives you a range. But again, I think you remember this from our other webinars. You see these two fields have an asterisk next to them. Anytime you have an asterisk, you don't need to answer that. That's just optional information. So on this one, the OK range and the feedback range, you do not have to answer that information. And again, once you do this, you press Insert, it sticks it directly into your program. And then you could go in and just do the next thing, or you can get out of it. And then it takes us into our stylus ball diameter calibration. And I just want to go through this quickly. I'm not going to go through all of them like I did on the manual side, because they're still very similar. It's just on the cycle side, you have to give it more information. So it asks you for a measure condition. Again, it asks you for the work diameter of whatever you're using to measure to calibrate your stylus, the approach center point for X and Y, how far into the parts you want it to go, the approach distance, measuring speed, measurement point, and then, again, your OK range and your feedback range. And again, the main reason it's asking for much more information is because it does do this automatically. So I'd emphasize again that when you use this, I would have tried to do all this in the manual side first to make sure everything works, to make sure you're sure that you have the right measurements. So try to do the manual side first. Then we cancel out of that. Now, I'm not going to go through any more of those, but if we go into the tool measurement, so see, now this one has a little bit more stuff in it than what it did on the manual side. Because on this, see, we have milling tool, turning tool, milling tool, turning tool, just different axes to measure. So if we go into the milling tool measurement, you know, with it, it's the measurement method. So it's asking for which direction we're coming from. Again, the condition, it's almost always going to be number one. The clearance plane, a moving speed, and how it shifts off the tool. Whether the tool's rotating or not rotating, the comp number. And the reason all these have asterisks next to them is because when you do this, you would have called a tool up first. So if you don't put anything, it assumes you want to put it into that value. But if you wanted to put it somewhere else, you could tell it to do that. So again, that's some of our measurement cycle. That was for X. But then like for the turning tool and Z, you know, again, it's still just fill in the blanks, measurement method, the condition, the clearance modes. You know, most of these are all fairly similar. And then you would press Insert, and it would put it into the program. But again, that's the difference between the two we went over so far. The first section was only the manual mode. Now we're going over the CNC mode. Then We have two other ones. I'm not going to go over them because they're basically the same thing as what we already went over. But then we also got work setting. Again, this is going to be similar to what we went over before. But I want to go over just a few screens so you see what they look like. If we select the Z-axis, again, it says fill in the blanks. If the control is going to give you any selections, they're down here as a soft key, so we'd say Z minus, measurement condition, 0, 0, 0, approach speed, and just fill in the blank. And then, again, we've got all asterisks there. We wouldn't have to answer this information, but you can if you want. Just depends on how much you want to fine-tune it. And then once you do that, you press Insert, and it sticks it into the program. But again, you definitely want to go through and do all your calibration cycles before you ever get into any of these. And again, with this, we do have a wide variety of different selections, because there we had probe in Z, X-axis in Z, Y-axis, outside diameter, outside width, inside width. Again, all the C-axis ones. Then, again, like you would do on a horizontal machining center. So you've got all sorts of capabilities with this. It will identify with almost any type of machine that you want to make it work on. So that's what's great about all these measurement cycles and tool measurement cycles. You can make it work for anything. And again, that goes back to the flexibility of manual guide eye. Also, we have all the different measurement cycles. And, we got 14 different of those also. And with this, like if we want to measure in X, I'm just going to select that one. Again, it's just X minus, measurement condition 1, 0 and 0, 0 and Z. The approach distance, it's just your arc length, 1 inch, and then a measurement speed. And then again, you tell it the comp number, what you want it to end up being, and the OK range. So basically what you're saying there is, say you bored something that was 2 inches in diameter, you'd say you want to shoot for 2 inches. And then if it was not within this range, plus or minus, then what it's going to give you back. You can either just have it go on or create an alarm or whatever. So it's very powerful when it comes to that. And then, also, again, this has a lot of different ones. We have 14 different measurement cycles also. So I'm not going to go through all these, but we'll just go pick one more out. And again, just like before, it's just fill in the blanks. Y minus, our measurement condition, 0, 0, approach this in 1 inch, and then our moving speed, 20 inches a minute. Okay? And again, what it does when it goes through a cycle, it finds it, backs off. It always measures everything twice. Although I think there is a parameter where if you didn't want it to do it twice, you could make it not do it. But I think it's better to have 2 touches. So those are all the different cycles. And again, with these cycles that we just went over, these all can be inserted into any FANUC CNC that has manual guide eye, even if you do the program itself offline. You can insert those into a standard G-code program that will read it, no problem. The calibration cycles, for the tool setter, it is a little different on this than what it was on the manual side. You have to tell it the measurement direction, the measurement type. You have to have a reference tool length. When you're doing it manually, it's a little different. The reference tool radius, if you're using a round tool to measure the diameter. And then you can either be setting, where it does put something in a variable, or to where it inputs it directly into one of your offsets. And then the setting destination, a reference value or an offset. Okay? And then you tell it which axes. and then the OK range. So at this point, we've sort of went through all the different cycles, and I know we've sort of went through them relatively quickly, but again, what I'm hoping for is that, after today, the main thing I wanted to go through was some of the opening things to set up, to emphasize in order to make this work, and to save you some of the headaches of going through all the alarms that I've went through in the past to try to set this up, to try to shortcut that for you, where if you try to do this, it'll make it much simpler for you if you try to set it up yourself. Okay? So at that point, let me jump back into my PowerPoint, and let me catch up on my PowerPoint, because I've sort of went through the same thing on NC Guide as what my PowerPoint was about. And at this point, I'm going to pass it back to Mark, because that's all I wanted to cover today. So I'll pass it back to Mark, where we can go over any questions that you might have.
Okay, Jody, I'm here, and that was really interesting. It's pretty clear that this probing functionality is simple but powerful, and I really like the intuitive nature of it. So that was a really strong message in your presentation. We do have some questions from our audience, so let's get started with those. Question here is, the probing routines, are they just calling Renishaw's 9,000 programs or FANUC-specific programs?
No, they don't use the Renishaw stuff. It's macro variable programs that FANUC has done. It's actually resident in the machine itself. No, the Renishaw macros are not in there, no.
Okay. How about, can you make vector movement measures?
Vendor? V-E-N-D-O-R?
Vector. No, vector.
Oh, vector.
V-E-C-T-O-R. Not sure what they mean, but that's my question. That's the question.
So you could probably measure something on an angle. Yes, that's some of the things that we're working on now, to do stuff, on an angle. Yes, you can do that. It's capable of doing that. Yes.
Okay. Okay. Question from earlier in the presentation. Will my machine do the manual probing right out of the box?
No, it will not. And that's, why, in the one slide, Mark, that, I want to emphasize that, number one, you want to try it to see if it does do it. And then, if it doesn't work, because basically, you could fill in all the values, but then when you press that measure soft key, if it doesn't do anything, because that's what you need to do, because, all the machines are so different, FANUC doesn't try to set up the ladder to where it'll work, because it's hard to set something up that'll work on everything. So that there'll be some ladder adjustment to make the manual probing work, for sure.
Okay. Here's another question. It just came in. It's getting back to the vector measurement. It says, I guess vector measurement is used when measuring a surface with a specified probing direction. Does that clarify something for us? Can you adjust that?
I think that'd be something that I'd rather answer. That's going to be a little bit different question from what I'd rather, if I could, have him call me afterwards, I'd rather talk about that then.
Okay, that's fine. Just as a reminder, everyone,
Yeah.
When you submit a question, they should be typed into the question pane on the control panel. It's on the right of the screen. And, we're going to try to get answers to all the questions, but we don't get to all of them while we're on the air, or if some questions are better answered offline, we'll take care of that at the end of the presentation. And, we're taping the presentation, so it'll be available online afterward. All right, well, let's get back to another audience question here. If using this in place of a Renishaw macro program, what is the FANUC macro program number?
Well, there's in the manuals that, I mentioned in the presentation, there's all the different P-code macro programs. All those numbers are in there because, you have to put them in a parameter so that the control will pick up the right macro.
Okay.
So off the top of my head, I'm not sure what they all are, but there's a lot.
Okay. Another question here. If the specification to the machine tool builder says this probing functionality needs to be there, can they have it ready before it is installed at my facility?
Yes, that is possible.
Okay.
Because really the different changes that, say like the manual probing that you have to do the ladder development, Mark. To do that, I mean, it's a fairly simple ladder change, but it's just a matter of getting your builder to do it. And if you would specify it, they would do it up front.
Okay. Does a spindle have to be oriented on a mill? That's the question. I guess we're talking about, obviously probing on a mill. Yeah, okay.
Yeah. Not necessarily, because most spindle probes today, when I first started, if you use a spindle probe, you had to orient the spindle probe so it would face the reader. The spindle probes today, number one, they don't have to be like that. There's 360 degrees where you don't necessarily have to do that. Although within Manual Guide I, if you would have, there is a selection for that where you could force it to orient the spindle if you wanted, but it does not have to be. You've got, again, that goes back to the flexibility, Mark. It'll sort of do whatever you want, but in most of those cycles, I don't know if you noticed it, but on a lot of them, it had a tab where it said, either force orient or disable orient for the spindle.
Okay. Here's another question from the audience. Can the probing cycle movement profiles be edited, or are the movement profiles preset?
Oh, no, it sort of does what it does. So, within the cycle itself, you really can't get in and mess with that. But, you can say like, I mentioned in there where it goes down and it does a double touch, right? But, you sort of define how far you want it to back off, the speed you want it to move in all of those moves. You get the capability of defining all that. So from that standpoint, it's fairly flexible.
Okay.
So hopefully that answers your question, I think.
Okay. If not, we can, double check that at the end of the program.
Right.
This question's a little more philosophical, and it's a really important one. Can I use this for quality checking?
Yes.
In other words,
it's possible to do that. Yes.
Okay.
Yes, and I've used it for that before.
Okay. There's kind of a little bit of some debate about, so-called buying off the part, when it's just used to probing on the machine, but you're seeing a lot of that by users?
Yes, because, especially on machining centers where maybe you're doing a high volume of parts and you wanted to go in there and check to see if this bore or whatever feature is in the right spot every time. And, and you can give it a range, and, then it'll come up and say, out of range or whatever. So, yes, it is capable of doing that. It is capable of doing that.
All right. Joey, it looks like we got time for one more question, and this is just circling back to maybe the beginning of your presentation. How long for initial setup? About how long can a user figure they're going to need to get everything set up for effective probing with Manual Guide I?
Well, if you'd already have the ladder development done, you could probably do it in about 3 or 4 hours. Because to be honest, I'm probably overly cautious because, I'll do one thing and check it 4 times before I do it, before I break the stylus off of the spindle probe.
Ooh.
I've done that too many times, so I've gotten cautious. So probably 3 or 4 hours if you already had the development done, because it's just a matter of going through and setting up all those settings screens that I showed, Mark.
Mm-hmm.
Once you understand what it wants, and that's what I was wanting to try to go over today, to make sure you understood what it wants there. Because sometimes if you look at the description of the field, sometimes they don't make any sense. So that's why I wanted to make sure people had a forum of, where they could look at to see what they should be, or, where they could ask me. But no, about a half a day probably, once you have the ladder development done.
Okay, that's good to know. Okay, Jody, looks like we're about out of time, so I just want to thank you again for presenting your slides, going through the presentation, and answering our questions. It's always a pleasure to work with you on these webinars. I've done a number of them with you, and it's interesting and it's fun. So thank you.
Thank
you. Yeah, and for all those attending this afternoon's session, you can contact FANUC America if you'd like more information. That information's on the screen right now. And if you missed any of the previous broadcasts in this series, and I highly recommend them, you can find all of them on our website. That's MMS Online, and just click on the Webinars tab, and then you can choose the ones you want to look at. So we really appreciate the time you've taken with us this afternoon, and hope you found it worthwhile. So thank you for taking part. And my thanks also to those who arranged this session and helped it go smoothly. And with that, this concludes our webinar. So have a great day, everybody. This is Mark Albert at Modern Machine Shop Magazine, signing off.